plane. Okay, and this is true. Okay, this is true where x is equal to 0.8 meters, and where x is equal to what? And x is equal to 2.4 meters. Is it 2.4? No, 3.2 meters. Okay. So from here, we are going to use, okay, I'm just going to analyze. Okay, so consider x is equal to 3.2 meters. Okay, we consider x is equal to 3.2 meters. So we know that the stress average will be equal to what? The stress average. So we are going to determine our stress average, which is equal to stress x plus by stress y divided by 2. So we know that stress y is equal to 0. Stress x is equal to what? 95.36 times 10 to the power 6 divided by 2. So this is equal to 95.36 power of 6. 47.68 times 10 to the power 6 Pascal. And then we determine our tau max, which is equal to our radius of the circle. So radius of the circle, if I were to draw this, we know that from here to here, we found this out that this is equal to 47.68. And we know that this distance over here for point what? For x is equal to 3.2 is 19.948. Right? So to determine the radius, this is the radius, and the radius is equal to our what? Tau max. Okay. So very quickly, you know that this will be equal to 47.68 times 10 to the power 6 squared, plus the shear is 19.948. So this in terms will yield 47.68 power 6 squared plus 19.948 power 6 squared. 51.685 times 10 to the power 6 Pascal. Let me do it again. 47.68 power 6 squared plus the 19.948 power 6 squared, square root of the whole thing, 5.51.6. So from here, stress max will be equal to 47.68 times 10 to the power 6 plus by 51.685 times 10 to the power 6. Right? So 47.68 power 6 plus by 51.685 power 6 is equal to 99.365 times 10 to the power 6 Pascal. Okay. And then finally, we're going to do x. Then we're going to consider x. Consider x is equal to 0.8 meters. Okay. So the stress average will be equal to what? So when x is 47.681, divided by 2 or plus by 0, right? Because one of the directions is equal to 0. 47.681 power 6 divided by 2 is equal to 23.841. And then we determine our tau max will be equal to same thing, 23.841 plus the shear we calculate is 39.897. Yes. .8. So before that is 3.2. Okay, so this is 0.8. Okay. So this will be equal to 23.841 power 6 squared plus by 39.897 power 6 squared, square root of the whole thing. 46.477 or 46.478 times 10 to the power 6 Pascal. So stress max will be equal to 23.841 plus by 46.478. So 23.841 plus by 46.478. 70.319 times 10 to the power 6 Pascal. Okay. So from here, right, where fracture will occur is X is equal to what? 2.4, because the stress max is what? 143.041. Are we clear? Okay, so this is where fracture will occur. Okay, I will do X is equal to 2.4. When X is equal to 2.4, the mole circle, because we have no what? We have no shear, yes or no? So this is our normal stress. This is our shearing stress element, rotate clockwise, anti-clockwise. So over here, this is our point Y and our point Z. And over here is our point what? Our point X. Yes or no? Because why? Because we have zero what? Zero shear stress. Okay. So from here, we sketch our circle. Right? And over here, our stress max happen to be equal to our stress X, which is equal to what? Which is equal to 147.0143.04 megapascal. So failure, from here, we can analyze that failure will occur at X is equal to 2.4 meters and stress max will be equal to 143.04 megapascal. Okay, are we clear? So again, what is so unique is you are able to do what? Failure what? Analysis, yes or no? Now you are able to go into in-depth failure. And if your projects, final year projects is in structure analysis, okay, one of you have to do this calculation. Are we clear? Okay, you're going to do 4 MO6 in your final year. Which year you're in now? Second year, third year, yes or no, right? This will be your one of your calculation that you do. And believe me, I'm the only one at McMaster that can check whether is it right or wrong. And you will know. Are we clear? Okay. If you look at week 1, can you remember this? Yes or no? Now I want you to read this question now. I want you to read this question now. Now, once you read this question, what are you going to tell me? Anyone? Mickey Mouse, easy peasy, right? Easy peasy, squeezy, and what? Slimy. Remember the first time when we did this, what was it? I took 4 lectures to finish this. Remember? And now, where you are now, I'm so proud of you. Where you are now, we just took what? You can do all the way. Are we clear? And you know how to analyze now. Okay? Do you all know what's a combustion engine? They call it ICE, right? In combustion engine, when nitrogen goes in and come out, what happened to nitrogen? Come on, you guys are better in chemistry than me. I'm partial colorblind. I can't do chemistry. What will happen when to nitrogen in combustion engine? It goes in as nitrogen, it comes out as what? Nitrogen gas. The only difference is a bit warmer. This is not a course where you attend this course, you are like nitrogen. You just feel a bit warmer, is it? No. You know how to what? Analyze. Are we clear? I think to me, that is more important than anything else. Right. I'll see you all on Wednesday.